Okay, children, there was this question asked that show that there is no AP which can have only prime numbers. All right, so that is what we've got to show, that there'll be that we cannot have an AP comprising of prime numbers only. All right, so we are going to do this proof by contradiction. All right, so we are first assuming that suppose there is some AP. उसने बोला था कि शो की ऐसी कोई AP नहीं होती है, हम assume कर ले रहे हैं. Let A1, A2, A3, these are terms of an AP in which we have only prime numbers. Okay, so all the terms of this AP would be prime numbers. All right, so now we are saying, consider, now this is a step that you'll have to keep in mind. That's a trick which is helping us get the contradiction. Okay, so this you keep in mind, the first term plus 1th term. Okay, so whatever is my A first term, uska plus 1th term हम निकालने की कोशिश कर रहे हैं if this was an AP. Okay, so let this be an AP having all prime numbers only, and say D is its common difference. So nth term, and कौन सा nth term लेना है आपको? First term plus 1, that is we are going to consider A1 plus 1th term. So by formula, A1 plus 1th term would be the first term plus number of terms, that is A1 plus 1 minus 1 by formula D. So इसमें क्या हो रहा है आपका, plus 1 minus 1 cancel हो जा रहा है, and you're getting the term as A1 plus A1D. Okay, then we can take A1 common from here. If you take A1 common, that means ये जो term हमने दिखाया था is coming of the form A1 into something. अभी ये क्या है, ये AP थी जिसमें सारे प्राइम नंबर्स थे, तो ये इसका ये कोई भी टर्म है, whichever term, nth term, rth term, first term, fifth term, 10th term, we are focusing on A1 plus 1th term. All terms should be prime numbers, क्योंकि हमने बोला कि इस AP में प्राइम नंबर्स ही हैं. ओके, सो दिस ऑट टू बी एन प्राइम नंबर. बट जब हमने इसको सॉल्व करा है तो ये हमें किस फॉर्म में मिल गया है, A1 इंटू समथिंग. ऑलराइट, तो A1 को एक प्राइम नंबर था, वन प्राइम नंबर मल्टीप्लाइड बाय समथिंग एल्स, सम अदर नंबर, देन 1 प्लस समथिंग वुड बी सम ऑफ द अदर प्राइम नंबर. Okay, or whatever number. So in short we can say we have got this particular term as a non-prime number, because prime numbers have 1 and the number itself only as the factor, जबकि इस नंबर के हमने factors दिखा दिए, इसके 2 factors आ गए हैं. All right, so this number cannot be a prime number. So that is, we would say, since we have got A1 as factor of this term cannot be said as a prime number. Okay, तो हमारा ये contradiction आ गया, क्योंकि हमने assume किया था कि ये AP is consisting of prime numbers, and जब हमने उसका एक particular term consider किया है, it clearly came out to be non-prime. So that means whatever was our assumption is definitely wrong. That is, we cannot have an AP which has only prime numbers as its terms. Now, all right, there was another one question here which was asked, which is find sum up to n terms of this kind of sequence. All right, so this sequence ka first job is to find the nth term. So nth term, you can see the numerators are odd numbers 3, 5, 7, not starting from 1, from 3. तो ये आपका 2n plus 1 form आया. First term में n is equal to 1, so 2 into 1 plus 1, 2 ones are 2 plus 1, that becomes 3. Second term के लिए if n is 2, 2 twos are 4 plus 1, 5. Okay, तो न्यूमरेटर्स हमारे कैसे चल रहे हैं, ऑड नंबर्स ऑफ द फॉर्म 2n plus 1. राइट, तो nth टर्म में हमारा 2n plus 1 आएगा. डिनोमिनेटर 1 स्क्वायर, 2 स्क्वायर, 3 स्क्वायर, तो फर्स्ट टर्म, सेकेंड टर्म, थर्ड टर्म, तो nth टर्म में n स्क्वायर. देन उसके बाद वाला टर्म, सो n plus 1 स्क्वायर. ओके, सो दिस इज हाउ वी कैन गेस इज आर nth टर्म. अब इस nth टर्म में वेरिएबल नीचे आ गया डिनोमिनेटर में. ऑलराइट, सो we cannot straight away put it to that sigma notation, so naturally we will have to split it to its partial fraction. Okay, so उसके लिए हमने partial fractions में देखा था, how do we split it? We say this whole term is n square है, तो एक बार आप लोगे a upon n, एक बार लोगे b upon n square. जब higher powers होती हैं, that is how we do it, all the powers we consider. Likewise second factor n plus 1 linear factor जो था, c upon n plus 1 and d upon n plus 1 to the power of 2, उसका higher power. So these are all possible factors we can have. अब कौन सा रहता है कौन सा नहीं, that we'll have to see. So for that again we'll cross multiply this here. So here one of the n gets cancelled, we are left with n plus 1 square. With b n square पूरा cancel हो जाएगा, तो only n plus 1 square. With c one of the n plus 1 will get cancelled, so we'll be left with n square and a single n plus 1. And with d n plus 1 square पूरा cancel होगा, तो खाली n square रहेगा. Okay, we've done partial fractions, right? How to do it? So cross multiplying, this is what you obtain. Now again you will bring it in a polynomial form. इसको open करो जितने आपके brackets हैं यहाँ पे, right? Squares and all open करके इसको पूरा polynomial form ले आओ. Then you will have to compare both the sides. Okay, comparing both the sides. एक्स क्यूब यहाँ है, सॉरी एन क्यूब. सो हाईएस्ट पावर से अगर हम स्टार्ट करें एन क्यूब, इधर कोई एन क्यूब का टर्म नहीं था तो कोएफिशिएंट इज नेचुरली 0 ऑन द लेफ्ट हैंड साइड. राइट हैंड साइड में एक ए में दिख रहा है एन क्यूब आपको, और यहाँ से कहीं नहीं आया, यहाँ प्लस सी में आया. तो एन क्यूब के कोएफिशिएंट्स में आ रहा है ए फ्रॉम हियर एंड प्लस सी फ्रॉम हियर. वन इक्वेशन. लाइकवाइज एन स्क्वायर कंपेयर करोगे, यहाँ एन स्क्वायर नहीं था तो अगेन 0 आ जाएगा. एंड विद एन स्क्वायर यू विल हैव अ 2a फ्रॉम हियर and a b from here, and you also have a c from here, and of course a d also. D में भी n square है. तो ये सारे coefficients आ गए on the right hand side. Next equation, आप n का पावर देखोगे तो n यहाँ 2 था, and यहाँ से n के साथ आपका एक a आ रहा है, यहाँ से 2b आ रहा है, and that's it. So a plus 2b is equal to 2. Constant अगर आप देखोगे यहाँ constant था 1, and यहाँ कोई constant नहीं है, only 1 into b. That's the only constant we are getting. तो एक वेरिएबल तो हमें सीधे मिल गया. By comparison, b is equal to 1. Put value of b in this equation. That way. So from this equation, you will get b substituted as 1. A's value can be evaluated. A is coming as 0. Okay. फिर ऊपर एक equation था a plus c is equal to 0. तो वहाँ से आपका c भी 0 आ गया. Right? ऐसे ही 1 by you know all the 3 variables. Next equation में रखो, you will evaluate your d as well. Okay? So you can see it that way. Just go through all the equations, keep substituting the values you are obtaining, and you find all the 4 variables. Once you've got all the 4 variables, you need to put back the value. So a came out to be 0, तो ये वाला term गायब हो जाएगा आपका. Right? 0 हो गया. b was 1, so only 1 upon n square. ये बचा एक. c भी 0 आ गया था तो ये फैक्टर भी गया. ये दोनों फैक्टर्स गायब हो गए. आपका खाली a n square with numerator 1 and n plus 1 square with numerator minus 1, because you got d as minus 1 and b as 1. बाकी दोनों 0 हो गए थे. Okay, so that nth term can, in partial fraction splitting, we can write it as 1 upon n square minus 1 upon n plus 1 square. तो 4 factors में से आपका only 2 remain. बाकी दो का automatically 0 आ गया because they were not existing. Alright. So next what did we say? कि now we had to find the sum of this sequence. So sum of the sequence means we have to add all the terms. T1 first term, second term, third term, so and so forth. Till n terms we have to add them up. So अब इस ये जो आपका expression आया था Tn, यहाँ से आप T1 रख लोगे, निकाल लोगे by replacing your n by 1. So if you replace n by 1, 1 upon 1 square, that is 1 upon 1. 1 upon 1 square या खाली 1 जैसा भी आप लिखते हो. Then putting n as 1, you'll get 1 upon 1 plus 1 2 square. Second term, putting n as 2, 1 upon 2 square आ रहा है, यहाँ से 1 upon 3 square. Next term में n is equal to 3 रखोगे, 1 upon 3 square minus 1 upon 4 square. तो ये sequence में ऐसे terms आते जाएंगे. Right? And the last term, tn, तो यही पूरा आ जाएगा आपका. चाहो तो to make it more clear, you can replace, you can also write the previous term tn minus 1 by replacing n by n minus 1. So you'll automatically see कि यहाँ पे आपका n minus 1 होगा तो n minus 1 plus 1, this will become minus of 1 upon n square, which will cancel out this plus of 1 upon n square from here. Right? So हमें क्या दिख रहा है कि alternately in between सारे terms cancel हो जाते हैं, only the first term which was 1 and the last term which was minus of 1 upon n plus 1 square. तो ये आपका पूरा sum आ गया. Alright, अब इसको आप और further solve करना चाहो कर लो. We can take LCM here, opening n plus 1 whole square here, cancel भी जा रहा है, simplified form में this is what you're getting your sum as. Okay.